Hello guys, this is Tafazwa from StackDev and welcome to my YouTube course. In this tutorial, we are going to look at Spring Native and we're actually going to learn how we can actually deploy a Spring Native application to Kubernetes, and we're also going to use a little bit of Istio where you're going to learn about how Ingress works and how gateways and virtual service work in a Kubernetes array. So as you might know, Spring 3 has actually been released, Spring Boot 3 has actually been released a few days ago with Spring Framework 6. And for the most part, Spring Native support has already been there, but the Spring team really took some time in terms of addressing some of the issues that Spring Native had, and also as well some bug fixes, and new milestones will actually be released. So for the most part, Spring Native is no longer an experimental feature. It's now something that is now available on Maven, and you can actually go ahead and install it on the go without much of a hassle. So some of the changes that Spring Boot 3 came with include the Java 17 baseline support of record, native executables, which is what we're mainly going to focus on this tutorial, and includes observability. So just to give you a little bit of background, so for the most part, traditional Spring applications, they would run, in terms of running, they would run on a fat JVM. And for the most part, these fat JVMs, they will be actually huge. That's why they're fat, right? And they would require, large memory footprint, and also they would take a lot of time to boot up, because this is how Java basically worked, right? Because for the most part, when an application boots up, it would require for resources, and some of these resources, we realize that after an application is boot up, right, some of these resources will only be requested during the execution or booting up of that application. But for the most part, Java, when it runs on pods or in containers, it won't actually necessarily release those resources, right? So which means there was an issue in terms of resource allocation, because for the most part, you would assign or allocate Java applications to large memory footprint, but at the end of the day, that memory size won't be something that you'll be using throughout the execution of your actual business logic of a specific service, right? So that issue, it was an issue, right, in terms of when Kubernetes and pods and containers came into play, because they like something that is short-lived, something that is a small memory footprint, something that boot up fast, and etc. And Java wasn't really supporting that. So how does now Java support that, right? So the support for native executables in Java is now being achieved through something that is called GraalVM, right? So GraalVM is simply an Oracle high performance JDK distribution written for Java applications and other JVM languages that actually provides a native image builder for building a native code and package it together with the virtual machine into a standalone native executable. So that's a lot of jargon, but for the most part, as you go along through the tutorial, you get to understand. Right. So how does GraalVM achieve this, right? So we are saying things that used to be done by applications at runtime, that includes compiling of source code, loading class and configurations, analyzing dependencies and dependency trees, and as well as executing code, right? All this stuff, they are now being done at build time, right? So this is how GraalVM achieves this, and it also achieves this using a process that is called ahead of time compilation, that uses the just-in-time compiler. By this, right, what this gives you is it will give you a native executable that is high startup time, which is what Kubernetes would want, right? And as well as a low memory footprint, which is again what Kubernetes would want. So which means we won't have issues where our applications or microservices that are written in Java, they are being constantly booted out because of resource issues. So all that process where GraalVM compile classes, load dependency trees, and etc. This is what is called the container first approach, right? So this is what traditional Java applications used to do. So they would, at build time, they would actually package the application. Then during runtime, they would now do all those things. So what it means is all these processes, right, from loading pass configurations until executing a code, right, all that processes would require large memory. So Java application or the JVM would ask for memory to run a specific Java application, and then at the end of the day, that memory won't be released, right? So which means the application would have memory that is not necessarily using, right? So with Spring Native now through GraalVM, all those things, they are now being done at build time, right? And what this will give you is it will give you something that is called a native executable or a JVM or a fedjar, but that is slightly optimized. That is different from the one that that the old JVM used to provide, right? So this is the whole philosophy of GraalVM and how the container first approach works, right? So for the most part, I also have a Quarkus tutorial where I'm going to detail about this GraalVM and how it works, so you can always check it out, right? So what is Spring Native? So Spring Native now provides support for compiling Spring applications to native executables using GraalVM, which is our native image compiler. So enough chit chat. So for the most part, that's what we're going to look at. So just make sure that you stay tuned and see you in a few. All right. So just quickly go ahead and jump to spring.io. So in this spring.io, we just want to initialize our application. So for our project, we are simply going to use Maven as our dependency manager. Then the language is Java. And for the group, I'm just going to put the name of the channel. And for the artifacts, I'm simply going to call it Spring Native. Then description, I can leave it like that, right? So the dependencies that we want to add is, if we click on add dependencies, as you can see, GraalVM native support is now out there, out of the box. It's no longer an experimental feature anymore. So just quickly go ahead and check that out. So for the most part, we just want to create a simple Webflux API with a single endpoint. We're not mainly going to focus on how to build APIs and stuff. I have videos for that. You can actually go ahead and check them out. So we're simply going to create a Webflux API, and what we're mainly going to focus on is how we can actually go ahead and build that API, dockerize it, put it in a container, deploy the container or the image to Kubernetes, and then spin up the pods, as well as configure our gateway using Istio Ingress. So we're going to configure our gateway as well as our visual service, so that we just get the full end-to-end Spring Native, how you can actually deploy it to a live environment. So for the most part, I'm simply going to use Spring Webflux, so I'm going to add that. I think I will also need Lombok. I'll add that. Then I'll also need I think R2DPC, right? And yeah, I think for the most part, that's it. That's all the dependencies we need for now. So I think we can simply go ahead and explore, and then click on generate. Not explore actually, but generate. All right. So once you generate the code, just go ahead and open it in your favorite IDE. So in this case, I'm going to use IntelliJ. So if I open my pom.xml file, you can actually see that I have my Webflux installed, my R2DBC, as well as my H2 for reactive H2 database, which is this one. I think the other one don't need it. I will remove it. I also have Lombok, and as well as this. So if you check your build section, there is now this GraalVM build tools, right, that are installed, right? So I'll explain what this as we go on. So one thing that I've done outside of the box is I've quickly initialized my Spring Webflux API. So let's just go through it so that you can actually go ahead and quickly configure that. So this has nothing to do with Spring, but it's just for testing purposes, just to make sure that our Spring Native executable is actually working. If you open your models, right, I've created a model called customer, right? So in this case, I'm using records, which is now also cool. And also supported, right? So I'm using a record. So for the most part, I'm using a record with these few fields. Then I also have a repository package. So inside my repository package, I'm simply extending the the reactive CRUD repository from the project reactor for our interface so that we'll be able to query our database. Then I'll also have another package. Inside that package, there's a customer service. So inside this customer service, what I'm simply doing is I'm initializing the customer first name only, right? So what I'm simply doing, so I've injected my customer repository, and inside this I'm using the bin application listener to actually run when we boot up our application. So this method will always be run when we start our application. So in this service, what I'm simply doing here is I'm loading the first names into a Flux, and then I'm going to map through the Flux. So inside the Flux, I'm just extracting the first name, and then I'll create a new object, customer. The other fields are now last name, surname, and then first name. So first name is the only thing that I'm injecting, and I'll flat map it and then save it to my database. So in this case, I'm using the H2 database, and then I'll subscribe and print, the DTO, the JSON object. I also have another method that is called fetch all customers that returns a flux of customer. Remember, I have a Spring Web Flux tutorial. You can always check it if you don't know about reactive programming. I'm simply fetching all clients, right? So in this case, I'm expecting to see 1, 2, 3, 4 clients, right? So that's our service. Then I also have a controller. So inside the controller is just an endpoint that is /API/customers that gets a stream of texts that is calling that customer service that we just created. Then one other thing that I've done is, if you open the Spring native, actually something that I need to do. So here I will say I need to enable R2DB repositories for our reactive web programming. Then one more thing that I have is I just have a configuration file that initializes a schema.sql in our database connection. So if you open the resources, I have a schema SQL file, right, that creates a table, and then this table is the one that we were initializing here. So for the most part, this is just a simple Web Flux API with a single endpoint, right? All right, so now let's quickly go ahead and start looking at GraalVM, right? So GraalVM, it actually, so Spring Native, it has 2 ways that we can actually go ahead and build our Spring Boot native applications. So the first way is you can actually use Spring Boot build packs support, which generates a lightweight container containing a native executable. Right, so you can use build packs, or you can always use the native build tools to generate a native executable, right? So we are going to explore both methods in terms of how we are simply going to achieve this, right? So if you open this, we have the build tools. So for you to actually get started, you need to make sure that you have installed GraalVM, right? So in this case, I'm going to use SDK main. So if I open my terminal, then I say SDK main, then I can say list Java, right? So what this is supposed to give me, in this case, I have my GraalVM here installed, which is version 22.3.19, right? So you need to make sure that you have your GraalVM installed, right? And then once we have your GraalVM installed, you also need to make sure that you have your Docker installed, right? So for the most part, that's basically it. So let's move on. All right, so once you have your GraalVM installed, you can always check if you are you can always check the Java version just to make sure that you are using GraalVM as your runtime environment. So for the most part, my runtime environment is now GraalVM, right? So which is good. So and also you need to make sure that your Docker is also installed, right? So for the most part, let's just quickly and build this into a native executable. So for the most part, if I run it normally, right? So I can say mvn, I can say spring boot run, right? So what this command does is it actually run your Spring Boot application by actually generating the native, the fed jar. All right, so as you can see, the application is run, and it is also show that print that I put. Then the IDs, they're incremented 1 to 3, since it's a primary key auto increment. So if I actually go ahead and check my source folder, there's a target folder, and then inside this target folder, you can actually see that we have our normal Maven classes, right? So if I actually go ahead and build it, instead of running it, so I'm simply going to say Maven clean, let's say Maven clean package, like this, right? So what this does is it actually builds a production ready JVM, right? So now it's successful. So if I refresh and open my target folder again, you can actually see that we have a fed jar that was being run, right, normally, right? So this is the normal way that we used to run, right? But since we have installed the GraalVM build tools, it actually means that we can actually go ahead and specify that we want to run our package natively. So the way you actually do it is simple. You simply say Maven, right? And you can say plain package, right? So you need to add an extension that is called pnative, right? So it's pnative if you're using Maven, right? Then it's something else if you're using Gradle, right? So if I say pnative, what I'm expecting, right? I'm expecting that GraalVM is supposed to use GraalVM and actually go ahead and generate the dependencies that we want to use, or run some specific goals that we want when we actually prepare our native executable, right? So if I open the target folder again, so in as much, you can actually see that we still have the 2 fed jars that we ran previously. But if you check, there are other folders or other builds that were generated, or other goals rather that were generated, right? You can actually see that it has actually done something that is called preparing metadata. So it has generated a folder called GraalVM reachability of metadata. So what this means is GraalVM, remember, like what we said, it does the things when we are actually building the application. So GraalVM has prepared the metadata that will actually be later on used that will later on be used when you register those specific classes for something that is called reflection. I think we'll look at it later or in future videos. But for the most part, you can actually see that there are certain goals that we run. So this is one of them. Then the other goal that was run is Spring AOT, right? So what Spring AOT means is it has done something that is called ahead of time compilation, right? So these goals that we actually run, they actually prepare GraalVM so that when we sort of like tell it to sort of like generate a native executable, it will use these actual goals or these metadata that have been generated to build that native executable. All right, so this is just slightly optimized JVMs that we actually generated with some targeted metadata that we would actually use for building a native executable. So for now, we haven't generated a native executable yet, but using the same GraalVM build tools, it actually also have another goal, which we can actually use to generate a Docker image, right? So the goal is actually called, you say Maven Spring Boot, and then you simply say build image, right? So what this is supposed to do is it's actually going to actually build an image and slightly optimized again image that we have this reachability for metadata. And as you can actually see, as the image is building, right, you can actually see that it's now pulling the image from something that by default it pulls from peg to build pegs package, and it's actually pulling the best image, right? So this best image is the one that would actually be used to generate our Spring Docker image that will be slightly built. It will be a JVM still, but it will be sort of like slightly optimized, right? So let's just wait for it to finish and then we'll take it through. Right, so as you can actually see, the build has successfully completed. Then if you can actually go ahead and check our target, we still have our reachability as well as our fed jar generated, so we can run them as normal. So java minus jar. So if I say java minus jar, then I say target. So this is the normal way we run our fed jar. So it's Spring Native, right? So you can actually see that the slightly optimized JVM is actually ran 4.4 seconds. So right now we're expecting that it has generated the Docker. So if I say Docker image, you can actually see that the Spring Native image was generated, right? So what you can actually see that it has pulled the image from peg to builds pegs, right? And it is pulled from the base image. So the base image is simply a JVM. It's not optimized at all. So if I try to run this, right? If I try to run the image, so let's just quickly try to run the Docker image. So if I say Docker run, then I can say remove, then again specify the port. So in this case it's 8080. Then I can say Spring Native. So in this case it's Spring Native. Then the tag is 0.0.1, then snapshot. The application is actually booted up, and again this is not a native executable. It's still a slightly optimized JVM. It booted up in 3.7 seconds, right? So how do we actually go ahead and generate a native executable? So just below our build configuration, I'm simply going to add a configuration that is called profiles. So what this does is it actually tell Maven to say when you actually run our Spring native build commands, it actually uses profile called native, right? And it will actually generate the execution that is called build native, and as well as package the goals. So this is the package that you simply need to add, right? So like I said, like what I've been doing all along, let me just close this and clear my terminal. There are two ways to generate native executable. So the first way is the old way that I did before. So I'm simply going to use the native buildpacks tools to generate a native executable by using the package command. So if I say p maven clean package p native, like so. So as you run this, right, again you need to make sure that your GraalVM is actually installed, because if you don't install your GraalVM, the build tools won't actually run. So right now, as you can actually see, right now it has started. The generation of GraalVM is now kicked in. So for the most part, you can actually see that GraalVM, we are using 23.3 the GraalVM, and it's now trying to actually go ahead. So right now it's initializing those classes like what we mentioned earlier, and then it will do performance analysis, right? So this will take a bit of time. All right, our build command is just finished. So if you actually go ahead and check the target folder, you can actually see that there's now a native executable, right? A runnable file that is called Spring Native. So it depends with the way you name your project. So mine, it was just Spring Native, right? So what has happened? GraalVM has actually used the metadata, the ahead of time processing that was generated initially to build this Spring Native. And it actually took some time. So mine, it took around 8 minutes because I was recording and stuff. So it depends what time, the time will depend in terms of what you're doing. So to run this native image, I will just simply say target, and then I'll simply run the Spring Native, right? So let's see. All right, so if you run this native executable, you can actually see that it started in less than a second, right? It's 100 milliseconds, right? So as compared to the other ones that were running, let's say in 3 seconds or 2 seconds, so this one is a native executable, right? So which means everything has been prepared and there's no actually need to do compilation of classes, compiling the code, building dependency tree, and etc. All those things would have been done at build time. That's why the build took a while to complete, right? So in this we can always compromise, right? Because if you are scaling the application, you want an application that will be able to boot up fast and also that is a low memory footprint, right? So in this case, you can actually see that the application is built in startup in crazy times, just within a second, right? In 100 milliseconds, which is amazing, right? So this is how you can actually use the first method of using the native build pack tools to generate a native executable. So the other approach that I'm going to use is I'm going to use the Spring Boot build pack support to generate a native Docker image, right? Just like what I did before. So in order for us to do that, so remember when we ran that command initially, when we ran the Maven build image command, it generates, so for example, if I say Docker images, right? So when you run this, right, it generates an image from a base, from the base image. All right, so to be able to build from to build a native executable in terms of a Docker image, a native Docker image rather than the best one that we used before, I need to specifically tell Maven to tell Graal that I can actually go ahead and use this configuration. So inside my build pipe plugin, I'm simply going to sort of like manually configure this. Right, so I have pasted a few lines of code here. So what I've added here is I've added a plugin that points to a tiny build pack, right? And I'm also putting a native image to configuration, environment configuration to true, and also I'm also enforcing it to use Java 17, right? Because with Spring Boot 3 it now has support GraalVM, it now support for Java 17, which means you won't face any errors or something. Then another configuration that I'm also going to add is I'm also going to add an execution, the process ahead of time. Since we manually do it, we have to sort of like redo it again. Then the other plugin kind of configuration that I'm going to put is I'm going to add something called add reachability for metadata. So remember we had two goals, the one for Graal that we're running and also the AOT. So the AOT I've put it here, then in the other plugin I've also added this. So just simply go ahead and copy and paste this. You should be able to actually pick this. So in this case, since this Maven build 2 was already there, it already comes with this where we put add reachability for metadata. I can simply go ahead and remove it. I don't need it anymore. So if I remove this, so remember it's two additional plugins that I just added, right? So in this case we now expect, so if I say Docker images again, we had an image that was built from base, so I'm simply going to delete all these images. So I'm going to forcefully delete them. So in this case I want to delete all of them, so I'll say Docker, let's say images, including the ones that are active and not active. So I simply want to remove all these images. So I'll clear my terminal. So if I say Docker images, you can actually see that there are no more images running. So let's quickly go ahead and run our Maven build image command that we ran earlier. So Spring Boot build image. So let's simply go ahead and run that code. Right? So what I'm expecting after this command is run, so instead of pulling our image from the base, we want it to pull from the tiny because we want a smaller image, right? So it's optimized quite nicely. And as well, since we have specifically tell it that we want to build a native executable, we'll sort of like Graal will sort of like do that. do that for us. So as you can actually see that it's actually now pulling the image from Tiny. So once our build is completed, if you actually go ahead and check the Docker images that were generated, you can actually see that we have built from Tiny, and in this case we have generated an image which is 133 MB in size, which is quite smaller than the other one. I think it was around 200 and something. So to run this Docker image, we simply do Docker run like what we did before. So we simply do Docker run. So in this case, we are now expecting that it to start as a native, right? So as you can actually see that our application has started in 0.082, right? Which is amazing, right? Which is less than 100 milliseconds per se. So this was an interesting thing, right? So we can actually see that our bootable, in terms of building our Docker image, our application is booted up in no time, right? So for the most part, if you get this far, this is how we can actually build our native executable using the build packs and as well as the build tools that comes with GraalVM and Spring Native. So in the next section of this video, we are simply going to look at how we can actually Dockerize this application and deploy it to Kubernetes, as well as installing Istio as our network gateway. So we're going to demonstrate how we can actually go ahead and do that so that it just becomes an end-to-end tutorial. So see you in the next one.